Alright, someone asked that I make a video going through some of these types of problems for the exam tomorrow. The first one I'm going to look at is y equals 7x minus 3. You know, if I want to find the inverse of this, the first thing I'm going to do is switch variables. X equals 7y minus 3. I move the 3 to the other side and I get x plus 3 equals 7y. Now to solve for y, x plus 3 over 7 equals y, and that is the inverse. Okay. Now, if we really wanted to sketch this thing out, I'd come down here, 1, 2, 3, and the slope of 7 is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And that would be y. And now, y, the inverse, is going to look something like this. Okay. All right. Moving on. If I wanted to find the inverse of y equals 2x squared minus 3, again, switch variables. X equals 2y squared minus 3, and we solve for y. I move the 3 to the other side, and I get x plus 3 equals 2y squared. Divide each side by 2, and I get x plus 3 over 2 equals y squared. And then take the square root of each side. And the square root of x plus 3 over 2 is equal to the inverse of y. Okay? And the graph of this thing, start a new page, 2x squared minus 3, looks like kind of like that. Okay? And then the inverse, which was the square root of x plus 3 over 2, is going to look a little something like this, right? Especially if we take positive and negative into account. Alright, next one. Y equals 7 to the x power. Okay. Again, if I want to follow the pattern, I want to find the inverse, x equals 7 to the y. This is an exponential equation. If I want to solve for y, I use a logarithm. And that's the log base 7 of x equals the exponent, which is y. And now if we want to sketch the graphs of these things, and that inverse, y would look like this, and the inverse of y would look like that. Okay, so let's take a look at a next one. Let's take a look at a logarithm problem where if we gave you something like the log base 5 of 125, and I said to evaluate that or find out what it equals. The idea is you set that equal to x. 5 to the x power equals 125. Well, 125 equals 5 to the third power. 5 to the x equals 5 to the third power. Therefore, x equals 3. Now, showing this work is enough of an explanation to show why 3 is equal to the log base 5 of 125. Okay. So that's all you really need to do there. The next one we might want to look at is one like log base 6 of 6 to the 7th power. And what does that equal? Well, let's see. First thing I'm going to do is I'm going to set that equal to x so that I've got something to work with on the other side. Turn it into an equation. This is a logarithm, so I think that what I want to do is turn it into an exponential. My base is 6. My exponent is x. And that equals the argument of the logarithm, which is 6 to the 7th power. Now, if 6 to the x equals 6 to the 7th, then x must equal 7. Okay. And again, this is enough work to show that you understand how to do it. Okay. Let's see. What else do we want to take a look at? Well, we could look at it the other way around. We could look at 9 raised to the log base 9 of 63. Again, I'm going to set that thing equal to x. This is an exponential equation. We've got a base raised to an exponent, so I think that what I'm going to do is turn this into a logarithm. And I can rewrite this thing, the log base 9 of x is equal to the log base 9 of 63. So if these things are equal, that means that x has to equal 63. And again, that's enough of an explanation to show how you got that answer and do that. If you'd like to add some words, that would be awesome. And then there were some logarithms to simplify, something like the log base 3 of 81. Well, that equals 4, because 3 to the 4th power equals 8 of 81. Right. Okay, so what else could we look at? Something like the log of 1 million. Right. Now, when we don't put a base here, we assume that it's 10. If I set that equal to x, that means that 10 to the x is equal to 1 million. And well, that tells me that x equals 6. Something else to remember is that the log, it doesn't matter the base. I could have 38.7 down here. But if I'm taking the log of 1, it always equals 0. Always. Now, if you think about that, it kind of makes sense. We look at the graph of a logarithm. Where does it cross the x-axis? At 1. So if this is x and this is a logarithm graph, that means that y equals 0. Well, you know what? That equals y. Alright, thanks. Well, I hope you enjoyed this and it was fun and that my voice did not lull you to sleep. Good night. Happy test taking.